Dear students, I would like to present to you the negative binomial distribution. Consider Bernoulli trials. That is, for every trial, there are two possible outcomes. The trials are independent, and small p, the probability of success remains the same from trial to trial. Now, in a sequence of such trials, my dear students, if we let the random variable capital X denote the number of that particular trial on which the rth success occurs, where r is some fixed integer, then the probability mass function of the random variable x is given by, as you can see on the screen, the probability of capital X being equal to some particular value small x is equal to x minus 1 c r minus 1 into p raised to r into 1 minus p raised to x minus r. और इस फंक्शन की जो सपोर्ट है, यानी x की जो वैल्यूज़ हैं जिनके ऊपर ये डिफाइंड है, they are not from 0 to infinity. They are from r to infinity at an interval of 1. Yani, x is equal to r, r plus 1, r plus 2, and so on. So, my dear students, this particular distribution is called the negative binomial distribution. और इसके दो पैरामीटर्स जो हैं वो क्या हैं? R and P. R क्या है? rth success, वो प्री-डिफाइंड नंबर जिसमें हम इंटरेस्टेड हैं, और P क्या है? The probability of success in any one trial. So let me try to explain all this to you with the help of a simple example. Suppose that a game consists of tossing a fair coin until we obtain the third head. अब ये जो मैंने कहा, इसमें आप डिफाइन कर लें. जिस चीज़ में हम इंटरेस्टेड हैं उसको हम सक्सेस कह देंगे. सो हेड इज सक्सेस. और चूंकि ये फेयर कॉइन है, therefore the probability of getting ahead or the probability of success is equal to 1 by 2, or in other words 0.5. तो इसी को हम स्मॉल p कहते हैं. सो स्मॉल p is equal to 0.5. एंड व्हाट अबाउट r? हमने अभी मैंने जो जुमला आपके सामने रखा वो क्या था? हमने क्या कहा कि suppose that a game consists of tossing a fair coin until we obtain the third head. So therefore r is equal to 3. अब अगर ये चीज़ें डिफाइन हो गई तो it's very simple then. We can use the PMF of the negative binomial distribution in order to get the equation that we need. So what do we have? The probability of capital X being equal to small x is equal to x minus 1 c 3 minus 1, क्योंकि r is equal to 3, into 0.5 raised to 3, क्योंकि उसके साथ क्या चीज़ मल्टीप्लाई होनी थी? p raised to r. So obviously, और उसके बाद उसके साथ एक और चीज़ multiplied by 1 minus p raised to x minus r. So what do we have here? 1 minus 0.5 raised to x minus 3. और इसकी जो सपोर्ट है, यानी जिसको डोमेन भी कहते हैं, x की वो वैल्यूज़ जिनके ऊपर ये डिफाइंड है, what are they? As I said a short while ago, r, r plus 1, r plus 2, and so on. तो यहाँ पे क्या होगा? 3, 4, 5, and so on. So what do we get when we combine all these terms? Simple form में क्या आ गया हमारे पास? The probability of capital X equal to small x is equal to x minus 1 c2 into 0.5 raised to x, where x itself is equal to 3, 4, 5, and so on. So, my dear students, now that we have this simple equation obviously I can compute as many probabilities as I want. So let me do that. I mean, I cannot go up to infinity, but I can compute quite a few of them. So as you can see in the table in front of you, if we let x be 3, 4, 5, 6, 7, 8, 9, 10, and we applied this formula and simply keep putting the values of x in this formula that we just obtained, what are the probabilities that we get? For x equal to 3, the probability is 0.125. For x equal to 4, it is 0.1875. And for x equal to 5, again, it is 0.1875. But then after that, it declines. For x equal to 6, it is 0.1562. And for x equal to 7, it is 0.1172, and so on. So if I draw the graph of this particular negative binomial distribution, what kind of a shape do I get? It is a moderately positively skewed shape. And students, you will be interested to know that in general, for various values of r and p, you will get a moderately positively skewed shape, as you can see on the screen here. But do note that as p, the probability of success in any particular trial becomes a smaller number, the shape of the distribution tends to normality. Iske baad, I would also like to talk about the mean and the variance of the negative binomial distribution. And without giving you any derivation here, I will simply give you the result of that derivation. The expected value of x, or in other words, the mean, is given by r into 1 minus p over p. और अगर आप 1 minus p को q से denote करें, then it is r into q over p. And what about the variance? The variance is equal to r into 1 minus p over p square. और उसका जब आप स्क्वायर रूट ले लेंगे तो जाहिर है कि आपको स्टैंडर्ड डिविएशन मिल जाएगी. I also would like to present to you the equation or the formula of the MGF of the negative binomial distribution. As you can see on the screen, MT, the moment generating function of this particular distribution, is given by 1 minus p over 1 minus p e raised to t, and this whole thing raised to r under the condition that t is less than minus log of p. So once you have the MGF, of course, you can take its derivative and do all that procedure that should be done, that is usually done in order to find the mean, variance, and higher moments of the distribution. Another very interesting thing that I would like to share with you, students, is that the geometric distribution is a special case of the negative binomial distribution. After all, what is the geometric distribution? Isn't it the one that comes into being when we say that we have a sequence of independent Bernoulli trials and we let the random variable capital X denote the number of that particular trial at which the first success occurs? यही कहते हैं ना जी. तो फिर अभी जो था उसमें क्या था? We said when the rth success occurs. So obviously, if you put r equal to 1 in the PMF of the negative binomial distribution, you will obtain the PMF of the geometric distribution. So this is the way they are related. It is, the geometric distribution is simply a special case of the more general negative binomial distribution.